Hello everybody, today is day 2 of rate of change. We talked about rate of change from tables yesterday, so today we are talking about rate of change in graphs. And this has a special name, it's called slope. So I put the little guys sliding or skiing downhill, right, on the slopes. So as a image for it to stick in your head. Rate of change on graphs is called slope. Okay, so let's dive right in. You have your notes and you're going to be following along. Today's warm-up shows a table. We've got something like what we learned about yesterday. We've got time versus distance. Time going up in minutes, and we've got distance in miles. A few questions for us to answer here. What row in the table is the x? Remember the x variable, or we're going to label as the x. The x has to be the independent variable or thing out of the two. In this case, that's going to be time, and time is usually a very common one that's always the independent variable because time is just time. It's going up and ticking along. It does not depend on the other. Distance, though, is the y-axis or the y variable. It depends on time. How far you go depends on how long, right, time has gone by. So time is the y, distance, sorry, is the x, and distance is the y. What is the rate of change? Remember from yesterday, first start with the formula. Rate of change is change in y over change in x. Remember what that symbol, that triangle symbol represents. It was called delta. That's the official name of the symbol, and that symbol is a shortcut. Instead of having to write change in, we can just do that symbol. So let's do change in y over change in x. What is happening in the y? We are going up by 3, looks like it. And what's happening in the x? We are going up by 5. Just want to make sure that all the rows, it's the same thing that's happening. So up by 3, so we write positive 3 over x, which is up by 5, so that's a positive 5. And it's just 3 over 5. I can't simplify this to anything. Of course, it could turn into a decimal, but I actually want you to leave it as the simplest fraction possible. Let's not even do decimals. Okay, so that is the rate of change. That table, the rate of change is 3 over 5. We could also decide to put units and say 3 miles per 5 minutes, or every 5 minutes or something. That's the rate of change, but let's stick with the number. All right, we are dealing with graphs, remember, today, so it may have been a while you've actually worked with graphs. Let's do a little graph review, just a few basics that I'm sure you know, but it wouldn't hurt. So let's label a few things on the graph. On a graph, the y-axis is the vertical. See, this one's labeled here. The y-axis is vertical. It goes up and down. The x-axis is horizontal. That is going left to right. Don't get those confused. It'll always be labeled on a graph. Okay, and then you need to practice writing the points. So we've got some shapes here. This triangle is right here situated. What point would that be? Well, whenever you write points, we write them in parentheses, right, separated by a comma. We always put the x part of it first, comma y. So it is always x comma y. That's how points are written. Often I do see mistakes still in 7th grade where people write the y first, and that's a completely different point. So since we know the left to right is the x-axis, this triangle is situated at 3, so the x part of it is 3, and the y-axis, it is situated at 4. So this triangle is at the point 3 comma 4. If you did that any other way, if you accidentally put the y first, that is a completely different point. That would be at 4, 3. That would be right here somewhere. You see, and that's different. You're off. So you have to do x comma y. Go ahead and label the other points and see if you remember everything from previous years. Pause the video, label these points by yourself, and then compare with me. The square is located at -3, 2. The pentagon is located at -5, and it's hitting the y-axis at -2. And the circle is situated at 1, comma, -5. Okay, those are your points. And this is how you label points on a graph. You will need to use this in a minute. All right, slope. So slope is that new word you're learning today, and you need to get used to what it means. What slope is, it is the rate of change, but it is rate of change between 2 points on a graph, on a straight line graph especially. We can't do slope if the line's all curvy and stuff. That would be something different you'd get into in high school. But for today, we're working with graphs that have perfectly straight lines like this one right here. And we can find the slope. That means the rate of change. On a table, we use that phrase rate of change. But for graphs, it means the same thing, but we use this word slope. Now, this should look familiar. Copy down this formula. Slope equals change in y over change in x. And the change in y is the vertical change. Change in x is the horizontal change. Remember we had a symbol for change in y. It's delta, or that triangle. So even for slope, we could use this exact same thing. So at least you're not learning a new formula. It's just that in a graph, you should also write this down, this is also called the rise. That change in y is called the rise. That means how much up or down. And the change in x is called the run. That means how much side to side. If this is all a little too much new information, new words into your brain right now, you'll see, just hang tight, just copy this down, you'll see examples. Okay, I have a challenge for you. From where you're sitting, your seated position, can you make forward progress without standing? Just you're sitting in your chair at your computer. Try and move 5 feet ahead without moving. Without standing, and no jumping allowed. Like, don't try and pick up your chair and just launch yourself 5 feet ahead. So try this. Is this doable? Is this impossible? What do you think? Technically, in this challenge, there's a little loophole. I'll see if you can figure that out. All right, have you tried it? Let's see. Here's the loophole. I didn't say what seated position you had to be. That's it. So you could sit yourself on a skateboard or in a wheelchair, or I guess some of you maybe were in a rolly computer chair, and you kind of got me and you rolled forward. Okay, so this is just a little visual I want to give you to remember a concept that must stay in your head. So there was a loophole in what I said, but 99.9999% of the time, you must rise before you run, correct? If you took out all these loopholes, you could not have gotten forward if you didn't stand up first. You must rise and then use your legs to run. Remember this phrase, rise before run. It is applicable in about 1 second. All right, finding slope. How do we find slope? So you'll have a straight line graph like this one. First thing you're going to do is pick any 2 points on a graph. Any 2. Just go up and down that line and put some dots. As you can see, they picked that one and that one. I will give you a hint that you should pick a dot, pick a point that's right on a corner, that's right and neat on a corner like that one. So that you know, because we know that that one has a point we can label, right? If you picked this, for example, if you pick that location right there, that's kind of in the middle of a box. It's not, I can't really pinpoint what that point exactly would be, but if it's on a corner edge, that's a good one. So I would recommend, I know it says pick any 2 points, but pick one that's easy to work with on a corner. Okay, so you've done that. We've picked 2 points. In this example, it's going to be that one and that one. Now we're going to find the slope, which is change in y over change in x, but remember it's called, for the purposes of a graph, rise over run. The rise part comes first. It has to be on top because remember, you must rise before you run. So starting from, you can pick the lower point or whatever, it doesn't matter which one you pick. Figure out from this point to get to that second point, how high up, how up or down, how much up or down do you have to go? And so you just count the boxes as you go up. So you're going from 1 to 4. That is 1, 2, 3. You are going up by 3. Okay, and then you get to here. So you're going up by 3, and then you got to turn, and to reach that point you've got to go to the right by how much? 2 boxes. So you're running 2. Your rise is 3. You went up, so it is a positive 3, by the way. And then you went to the right towards positive numbers, so that is also a positive 2. There are situations, of course, where these numbers could be negative. So that's 3 over 2. Just keep it as the fraction. If it's possible to simplify, simplify, but 3 over 2 in this case cannot be simplified. So the slope of this line, we will say slope equals 3 over 2. Okay? You'll only get more familiar with this as you practice some more, which we will be doing today. Next example. Graph the data about plant height for a science fair project, then determine the slope of the line. Okay, so we were given a table like the ones that we saw yesterday. We need to take the points on this table and graph them right here and make a line in this graph. Let's do that. So the week is going to be the x variable or x-axis. The plant height, that is the dependent, will be the y. So you can actually just make the points by putting parentheses and comma. That is the point 1, comma 1.5. But right, you see how instead of writing it off to the side, I just put the parentheses and comma right there. Okay, do that for every single one. And we can graph these points. Let's start with the first one. So the first point is at 1 and 1.5. So that might be there. Correct? It's between the 1 and the 2. Right there. Next point is at, so we're done with this, 2, comma 3. So 2 on the x-axis, 3 on the y-axis, right there. Then we're at 3, comma 4.5, about there. You see our line is kind of getting built. And then 4, comma 6, right there. Okay, we connect the dots and make our line. Okay, and we've got our line, so we've done the first part, graph the data about plant height. Now we need to determine the slope of the line. So remember, how do we find slope from a line? We pick any 2 points. Let's pick 2 good points that are easy to work with, that are on the corners. Let's not do these 0.5 points, right, because they're on the corners. Let's do this one, which is right there, and that one. They don't have to be points that are right next to each other, by the way. So maybe that's a little too... Okay, so we'll pick this and this to focus on. From one point to the other, first we need to figure out how far up are we going? That would be the rise. So you're going from 3 to 6. How many boxes of a jump is that? That is up by 3. And then we're going from there over to reach the point, our run. That is from 2 going to 4, or that's 2 boxes. So that is going to the right, that is a positive 2. Okay, so we've got our rise over run. Remember slope. And in these beginning days of this topic, I do want you to always write, at least use the symbol, slope is change in y over change in x. Or you could have written there rise over run. Maybe, yeah, I think I should do that since that's the new terminology. Rise over run. And we figured out that the rise was 3 and the run was 2. And that is our answer. That's our slope. Awesome. Explain what the slope represents in the work zone. We could say the plant is growing 3 feet or 3 centimeters every 2 weeks is how we would describe that. Okay, we've got a lot of graphs for you to play with and just get very comfortable. All you need to do on every single one of these graphs, this is a separate practice page that you printed out. All you're going to do is find the slope and get really good at doing that, because this is going to build on something else for next week. So you need to be able to look at a graph and not make mistakes and figure out the slope. I will do a lot of these with you. You can pause the video and try them out by yourself first and then hit play and watch me. But here we go. Slope. I want you to write for every single one that the slope is rise over run to remind yourself. And then from there you're going to plug in your numbers. I don't want you to make the mistakes of putting the run, the x over the y, you know. Alright, so our first step is to pick points. Actually, they've helped us out and given us some points to be helpful, so we could go with what they've given us. Let's do, starting from this point, we need to go up. That would be our rise, so you know it's positive. Up by how much? 1, 2, 3, 4. We went up by 4, or 4 boxes. And we need to go over to the right to meet that other point, and we are going to the right by 2. Plus 2. So our rise is 4. If it's at this point you can drop off that plus sign because it's a positive 4 over 2. And what does 4 over 2 reduce? It reduces to 2, and that's it. That is the slope of that line. That's all you have to do for every single one. Okay, make sure you understood how that works. On this next example, where do you start, right? Do you start here and try and meet this point, or do you start at the right and try and go up to that point? It does not matter, and you'll see. Let's try both ways. So if we start at this point, in order to get to that one, we have to travel down, actually. Down by how much? That's going to be 1, 2, 3, 4, 5. So since we are going down, that's going to be a negative 5. And then we are doing our run over 1, 2, 3, 4. And we're still going to the right, so that is going to be positive 4. So our slope is going to be negative 5 over 4. It does not simplify, we just leave it at that. Alright. Next one, from there to there. I would just always, maybe as a rule, start with the dot or the point that's on the left and try and get to the one that's on the right. So we're going to be going up by a lot here. We're climbing all the way to there. How much of a climb was that? 1, 2, 3, 4, 5, 6, 7. We went up 7. That's the rise. Over by 1, 2, 3, 4, 5. To the right by 5. Notice that on the graph I'm putting my plus signs, but when I come down here I know that that is just 7 over 5. I don't want to simplify that to a decimal. I'm totally fine leaving this as a fraction. All right, a few more. Start with the point on the left and try and reach the point on the right. This one's going down by 1, 2, 3, 4, 5, 6, 7. Down 7, so it's going to be minus 7. 1, 2, 3, 4. 4 to the right, so that is a positive 4. So that is negative 7. Rise, the up and down part always comes first, over 4. Cannot be simplified to any other fraction. Leave it at that. Okay, I've worked out a few of these and hope you can check your answer as well. Now this one can be simplified over here. Negative 2 over 8. Let's ignore that negative sign. We can just attach it at the end. But 2 over 8 reduces to 1 over 4. Then we just stick the negative sign with it. And so our final answer should be negative 1 over 4. That would be the simplified slope. All right, 3 more examples. Do it by yourself and then watch me. All right, number 7 also is a slope of rise is 6 over 2. 6 over 2 simplifies to 3. That would be your answer. Let's do these 2 more together. Here's the point, and where's the other point? Right there. So we would need to travel down by 2, right? So that's going to be minus 2. And to the right by how much? 1, 2, 3, 4. So negative 2 over 4. That becomes 1 over 2, simplified to 1 over 2, and we attach the negative sign right next to it. Just normal simplifying fractions. Here's the point and here's the point. Okay, we're going up by 1 and then over by 1, 2, 3, 4, 5, 6. So 1 over 6. Okay, you're just going to have to do a lot of practice with slope. I'll be putting some practice up. It's just doing more and more graphs and getting used to that rise over run. Let's summarize types of slope. We saw there's different types of lines, and you just need to sort of label a line that goes, think of skiing, a line that's going up. Think of a person trying to go uphill. This would always have positive slope. The number that you get, that one's going to be positive. A person going downhill with the line slanted down, that would always give you negative slope. Okay, let's go back to a few examples. Okay, you see how this one, the line is going down, and we got a negative answer. Same, this one, the line's going down. You see we got a negative answer. All right, what about if we have a flat horizontal line? That is going to be 0 slope. Okay, think of a person standing there and they can't really, I like to use the skiing analogy. They can't really ski if it's just a flat line, right? 0 skiing possible. So that's going to be a 0 slope, a flat horizontal line. A vertically flat line, just going straight up and down, this is something we called undefined slope. Like we can't even, there's no number or not, we can't even describe it or categorize it. It's just called undefined. Same thing, a person trying to ski with a straight cliff, there's no skiing going to happen there either. They're just going to fall to their death probably. And so these are the 4 different types of slope: positive, negative, 0, and undefined. You will hardly be asked really to label this as a test question or anything, but it's something to check your work. If you have a line going up, look at number 1. Yes, you got a positive answer. It's just a way to check yourself. You have this line on number 2 going downward. Did you get a negative slope? Yes, you just check yourself. All right, for your exit ticket, it's something very similar to that previous example we did. You're given a table here, and you will be asked to graph it. Take those points and graph it, and then find the slope. How do you take those points? Well, you pull out each row, and you do 1, 50. This one will be 2 comma 100. These are points already on the graph that you can do. 2, let's see, 1 comma 50, 2 comma 100, 3 comma 150, 4, 200. There's your line. You need to pick any 2 points and figure out the slope. Why don't we just pick those first 2? So starting from point number 1, going up. Yes, you're going up by 1 box, but look at these numbers on the side. You're going from 50 to 100. So you're going up by 50, over by 1. So the slope here is 50. All right. That wraps up slope. I will put additional practice for you guys, and you're going to get really good at this. It's not too bad. Good luck on your homework.